Hey everybody, hope you had a great weekend. Today we are going to be moving on to talk about symmetric and skewed distributions of histograms. Now, I posted a picture on Friday of box and whisker plots and talked about how we had symmetric, skewed left, and skewed right. So, refer to that picture also when we're talking about this, and this definitions goes with those definitions that were attached to that picture. So a histogram is kind of like a bar graph, but each bar is connected to each other. So, and the reason they do that is because they're intervals. So with this histogram here, it looks like that there's a tail here, and then the majority of the data is on the right-hand side. So it's a bit confusing here because the majority of the data is on the right-hand side, but it's called skewed left. And the reason that is because the tail is on the left-hand side, meaning that these numbers here, there's not as, they don't make up the majority of the numbers, but they will mess up the average and things like that because it's going to pull it in this direction to the left. So that's why it's called skewed left. The tail of the graph extends to the left. Most of the data is on the right. Now symmetric just means that it's about a mirror image. So you get to the top and then it's the same to the right as it is to the left. It doesn't have to be exactly the same in order to be symmetric, but it should be close to the same. And then skewed right means just the opposite of what skewed left is. The majority of the data is on the left-hand side, but the tail extends to the right-hand side. So there's some data down here, and the majority of it is right here. So this part is skewing it right. So normally if we had in-class sessions, I would show you how to make a histogram, but since you're going to be doing all your work on the online textbook, I just attached a picture of the histogram here. So a lot of these questions are going to say display the data in the histogram. I posted those displays for you so you don't have to do it. For your big ideas work, it's a sliding scale. So I'm just going to show you how to make a histogram so that you know. So first thing you have to do is you have to look at the frequency that's coming over here and the interval. So the interval is 1 through 8, 9 through 16. Notice these are all the same. So every single one of these has 8 digits in it. And this tells you how many times it comes up. So number of tickets sold, 1 through 8, that happened 5 times. 9 through 16, that happened 9 times. 17 through 24, that happened 16 times. And so then you load it up into a histogram like this. So if you look at this, we have to say describe the shape of the distribution. So let's look at it. Well, it looks like we have most of the data right here in the middle. On the right-hand side and left-hand side, they look a little bit off. Then these look pretty much the same. So this would be symmetric. So this data, the distribution would be symmetric. I know you might be saying it's not exactly the same, and you're right, it's not exactly the same, but it'd be symmetric because it's close to being the same on both sides. All right, so that would be the shape of the distribution for this one, would be symmetric. All right, for this one here, same idea. So I want you to give this a look. Look back to that first picture. If you want to pause the screen and look back yourself, go back in the video and try to say, what do you think this is? Do you think it's skewed left, skewed right, or symmetric? All right, well, if you said that you thought it was skewed, you'd be correct. So now the question is, what direction is it skewed in? All right, so it looks like we have a lot of the data right here, and then there's a little bit of data here. So this is what's called skewed left, because the tail is on the left-hand side. So this we call skewed left. All right, so the shape of the distribution is skewed left. So depending on if the data is skewed or symmetric, depends on what measure of center or variation would best represent the data. So when the data distribution is symmetric, it's best to use the mean to represent the center and standard deviation to describe the measure of variation. When data distribution is skewed, you should use the median as your measure of center, and then the 5-number summary as your measures of variation. Remember, the 5-number summary is the least value, the greatest value, and then the quartiles in the interquartile range. But the quartiles, least value, and greatest value would be the 5-number summary. So there's 3 quartiles, least value, and the greatest value. So we're not going to find those with this, but we're just going to say that those are the best measures of center and variation. So with these types of problems, it's not like we're going to have to find the mean or find the standard deviation. We're just going to say that those would be the best measures of center and variation if it's symmetric. And if it's skewed, the median and the 5-number summary would be the best. All right. So since you're going to have to do this on the big ideas, I'm just going to kind of tell you how you'd figure out how to move, how many go into each one of these bars. So when you're given a large group of numbers like this, it says, display the data in histogram using 6 intervals beginning with 1 through 20. On big ideas, they will give you the intervals, so you don't have to worry about that. You're just going to have to worry about finding out the frequency. So if you know the first one's 1 through 20, you would just go through this list and find out how many numbers are in that category. So we have 5, and then there has to be one more. Well, I'm confused because I can't find another one. It says that there's 2 here. You see that, right? It says that there's 2. I only see 5 in between 1 and 20. I got this picture right from the book. I would say there's only 1. Maybe this picture's wrong. Sometimes that happens with a textbook. But that won't mess with our numbers too much, at least with our answer here. But yeah, so anyway, to find it, you would count how many go into each interval, and then you would slide the bar on there. So on big ideas, there's going to be a sliding bar, and you just slide it up and down to show how many are in each interval. Hopefully it doesn't give you any problems like this one gives me, unless I'm seeing something wrong, but I think there should only be 1 in the 1 through 20 interval. All right. But let's just look at it because the other question is which measures of center and variation best represent the data. So the first one to look at, is this skewed or symmetric? All right, well, it looks like it's pretty symmetric. I wouldn't say that's perfectly symmetric, but for the most part, most of the data is in the middle. They're about the same on both sides, so I would say that it was symmetric. So since it's symmetric, what's our best measure of center? Well, that would be the mean. And then again, since it's symmetric, the best measure of variation will be standard deviation. All right, so since it is symmetric, those are our best measures of center and variation. Okay, so then the next kind of problem you might get is they might give you 2 things. This one they say are about emoticons, which I guess is what came before emojis. Graphic symbols that represent facial expressions. I think that's like the semicolon and the parentheses to be a smiley face or a winky smiley face or something. So they're used to convey a person's mood in text message. So this must have been made before the emojis. But the double histogram shows the distributions of emoticon messages sent by a group of female students and a group of male students during 1 week. Compare the distributions using their shapes and appropriate measures of center and variation. All right. So basically, we're just looking at 2 things. We're comparing the measure, how it's distributed. So if you look at the female students, it is symmetric. So since it's symmetric, the best measure of center would be the mean. The best measure of variation would be standard deviation. If you look at the male students, it's definitely skewed. I would say that would be skewed to the right. And since it's skewed, the best measure of center would be the median. And the best measure of variation would be the 5-number summary. So again, when it's symmetric, it is the best measure of center is the mean. Best measure of variation is standard deviation. If it is skewed, either left or right, the best measure of center is the median. And the best measure of variation is the 5-number summary. All right, so that's it for today. That's what we're going to be doing. So, if you have any other questions, please write them down, attend the Google Meet, or email me. All right, guys, well, have a great rest of your day.